So let's try out adding and subtracting a few more fractions. First, we need to find our least common denominator, our LCD, which in this case is going to be 2, and we got an x and an x squared. In other words, we need to take the x squared, and that takes care of all these three. So let's multiply each fraction by the missing piece for the least common denominator. X squared is missing here, 1/2 times x squared over x squared, plus 2x times 2x over 2x, minus 3x squared times 2 over 2. So we get x squared over 2x squared plus 4x over 2x squared minus 6 over 2x squared, and can now go ahead and add or subtract the numerators. X squared plus 4x minus 6 over 2x squared. And our domain restriction, going back to original form, we see that x is not allowed to be 0, and that's all we can find. That's our domain restriction. So for our next problem, let's first write the two fractions in fully factored form. We have had these exact same two fractions earlier in this lesson, so the first one is x over x plus 2 times x minus 1, and the second one is 1 over x plus 2 squared. I'm going to need a little bit more room for this problem, so I'm going to build my LCD up here, and the LCD is x plus 2 we need in there, but we need it with the highest power, so x plus 2 squared, and we need the x minus 1 in there, and there it goes. So let's write our two fractions that need the missing pieces. We need 1x plus 2 for our first fraction, and we need an x minus 1 for our second fraction. Now we're going to multiply our fractions, and I'm going to distribute the numerators right away. So we get x squared plus 2x over x plus 2 squared times x minus 1 minus x minus 1 times 1 is just x minus 1 over x plus 2 squared times x minus 1. Now for our next step, let's be careful here. Let's realize that this is subtraction, and the subtraction counts for both terms in the parentheses, so we need to distribute the negative sign. So make no mistake here, and then we get x squared plus 2x minus x plus 1 minus times the minus. Remember, our denominator stays the same, and fully simplified, we get x squared plus x plus 1 over x plus 2 squared times x minus 1. So much for that. And let's make sure that we always circle our final answers. And we cannot forget our domain restriction here. And for domain restriction, we're going to go back to our fully factored form, and that tells us that x cannot be negative 2, and x can also not be positive 1. Those are our domain restrictions. Now let's move on to something a little bit more complex. simplifying complex fractions. Complex, get it? Haha. So to do that, we combine the numerator into one fraction, and we combine the denominator into one fraction, and then we flip and multiply it, just following our usual KCF method. So these complex fractions can sometimes look a little scary, so let's first rewrite them as a division problem, and then we realize that is a lot like the things we have been doing. Okay, and next we're going to factor them fully. So we get x squared over, and yet again we have a difference of perfect squares here, our good old friend, and that tells us we got x minus 1 times x plus 1 divided by 3x over x plus 1. And now we're going to go ahead, keep, change, flip. We're going to keep our first fraction the way it is. We're going to change this into multiplication. We're going to flip our second fraction. And now we can start and multiply. First though, we're going to see if we can simplify anything out. We have an x plus 1 that we can simplify, and we have an x here in the denominator, and that can be simplified against our x squared. That leaves only one x in the numerator. So our final answer is x over 3 times the quantity x minus 1. And of course, we need to check for domain restrictions. Remember, domain restrictions we need to look for in both denominators as well as in the numerator of the second fraction, the one that got flipped. So our domain restrictions are x cannot be equal to positive 1, negative 1, which is also a domain restriction from this denominator, as well as 0 from the numerator 3x, which gets flipped and turns into the denominator further on when we do the multiplication. So let's do the same thing with our second problem. Let's rewrite it as a division problem. 2 minus 1 over x. But if it's a division problem, let's not forget to put parentheses around it. Divided by x. So the x is really x over 1 if you think about it, and so is the 2. So now we have denominators here, and we realize that our subtraction, which was the numerator of our first complex fraction, does not have the same denominator, so we can subtract these two fractions. The least common denominator is x, so we need to first multiply our first fraction by x over x, so we can then subtract it and continue on with our work. So then we're going to have 2x over x minus 1 over x divided by x over 1. In other words, 2x minus 1 over x divided by x over 1. And now we can flip our second fraction, so we can make this a multiplication problem. And we get 2x minus 1 over x squared. And in terms of domain restrictions, you may ask, x cannot be 0 because we have it in the denominator of our first fraction, and we also have it in the numerator of our fraction that later got flipped. So let's go ahead and write this down. X such that x is not equal to 0. And that's that. So this next problem may look a little scary at first, but let's just do everything we have been doing and we're going to be just fine. So first we're going to rewrite this as the division problem. 2 over 4x plus 12 divided by, nice set of parentheses, 4 over 2x plus 6 plus 1 over x plus 3. Now, before we do anything else, let's see if there's anything that we can actually factor out. In our first fraction in the denominator, we can factor out a 4, and we are left with x plus 3 in parentheses. What about our second fraction? We can factor out a 2 in the denominator and get x plus 3, and nothing we can do in our last fraction, so let's just copy it down as it is. And next we're going to take another look, and we see that we can simplify those fractions also. 2 goes into 2 and into 4, into itself of course once, and into 4 2 times. And again 2 goes into 4 2 times and into itself just once. So we have a set of fully simplified fractions now that says 1 over 2 times the quantity x plus 3 divided by 2 over x plus 3 plus 1 over x plus 3. And we see that we are in luck. We can add these two fractions in the back together. They already have the same denominator. Otherwise, we would of course have to look for least common denominator. In other words, we got 1 over 2 times x plus 3 divided by 2 plus 1 is 3 over x plus 3. And now we're going to go ahead and do our keep change flip. 1 over 2 times x plus 3 times x plus 3 over 3. And now we can even simplify more. The x plus 3 gets simplified, and all we're really left with is 1 over 2 times 3, which is 6. Who would have thought that this is going to be the final answer of a very complex, get it? Complex fraction up here. So let's not forget about our domain restriction. I ran out of room here, so I'm going to put it up here. X such that, what can x not be? Looking at a fully simplified and factored form, here we have 3 times the same factor, and that means that negative 3 is the only domain restriction that we have. On to our last example for the day. Let's rewrite our fraction as a division problem. 1 plus 1 over x divided by 1 minus 1 over x. Let's not forget our parentheses around. So next we are going to give them denominators and find least common denominators, which in this case is x. So the first fraction needs to be multiplied by x over x, and also in the second fraction, which leaves us with x over x plus 1 over x divided by x over x minus 1 over x. And now we can go ahead and add or subtract our numerators to get x plus 1 over x divided by x minus 1 over x. And have you noticed how now we don't need parentheses anymore? See, that is the thing, that our fraction bar here has its own built-in parentheses. That's why we also call it one of the grouping symbols. So then let's do our keep change flip. x plus 1 over x times x over x minus 1. And the x's cancel each other out, and we are left with x plus 1 over x minus 1. Excellent work, you guys. And before we leave here, let's look at our domain restrictions. From the denominators of both fractions, before we flipped it, x cannot be equal to 0. But from the numerator of the fraction that got flipped, x can also not be equal to positive 1. And those are our domain restrictions. Okay, that's it for today. So just realize that for our last exercise, simplifying complex fractions, we pulled from all the things that we have seen in this lesson and the previous one, adding, finding common denominators, then multiplying or sometimes flipping, and then multiplying the fractions. So that's where all of these skills come together. All right, that's it for today, and I will see you in class.